Average and Instantaneous Rates of Change by Carly Fung. Rate of change is the speed at which a variable changes over a specific period of time. There are two types of rates of change that I will be discussing in this video, starting with average rate of change. Average rate of change is the change in the value of a quantity divided by the elapsed time. This equation, when expanded, looks like this. The average rate of change is also known as the slope of the secant line, which is a line that touches a function at multiple points. As shown, the line touches at point P and point Q. Here's an example. Determine the average rate of change from x equals 5 to x equals 9 on the function f of x equals bracket 2x minus 4 bracket to the 3 plus 3. Using the new formula, plug in f of 9 as f of x2 and f of 5 as f of x1, and similarly, 9 as x2 and 5 as x1. Then, expand using the rational function given and solve. After solving, you should end up with an answer of 632 as the average rate of change. Instantaneous rate of change is the exact rate of change of a function at a specific value of the independent variable. However, this is just an estimation, as we are making the x2 variable very, very close to x1. For example, if x1 is 3, we make x2 3.001. The instantaneous rate of change is also known as the slope of the tangent line, which is a line that touches the graph at only one point in the given interval. Here's another example. Determine the instantaneous rate of change of the function f of x equals bracket 2x minus 4 bracket to the 3 plus 3 at x equals 6. Using the formula, in order to estimate the instantaneous rate of change at x equals 6, plug in 6.001 as f of x2 and 6 as f of x1. Then 6.001 as x2 and 6 as x1. Then, plug these values back into the rational function and into the instantaneous rate of change formula. This should give you a value of about 384.1 as your instantaneous rate of change. You now know how to find the average and instantaneous rates of change and apply these learnings to rational functions. I will now explain how to apply these concepts to both trigonometric and exponential and logarithmic functions. Trigonometric functions use rates of change the exact same way rational functions do. It is just important to remember that the tangent lines in a trigonometric function at the maximum and the minimum values are horizontal, making the slope and furthermore the rate of change 0. Also, the absolute value of the slope of the tangent is the greatest at the halfway point between the consecutive maximum and minimum point of a function. The concept of calculating rates of change in exponential and logarithmic functions is also the same as the other two. However, here you can use your calculator as a tool to help you. It is easiest to explain this concept using an example. The table provided shows the correlation between customers at VideoFlix and year. Assume year 1 is 2001. Use your calculator to graph the data, and secondly, estimate the instantaneous rate of change in year 2. To graph the data, first click Stat Plot and turn Stat Plot 1 on. Next, click Stat and then Edit. Once here, enter the year numbers in L1 and the average number of customers in L2. Once you have completed the table, click Graph. This will allow you to see the general movement of the data. This is the completion of Part A of the question. In order to do Part B, you must again click Stat and then go to Calc, where you will eventually find an option to click on ExpReg, short for exponential regression. Press this and then the Calculate button, and you will be redirected to an equation that represents the data shown here. Since you are estimating for year 2, plug in 2 as x into the newfound formula, and then put it into the rate of change formula. You should get negative 88.37 as your rounded answer. You now know all about average and instantaneous rate of change and should be able to apply it to 3 different types of functions: rational, trigonometric, and exponential and logarithmic. To recap, average rate of change is the change over time, whereas instantaneous rate of change is at a specific time. Thank you for listening, and I hope you understand.